Welcome back to our live training session. In this tutorial, we're going to finish up our base map creation process that we began in our last tutorial. So in the last tutorial, we set up our background details, setting up our inputs and outputs and all the configuration settings so that we can move into this tutorial and finish out the base map creation process, configuring our two-dimensional and three-dimensional tables. We have a lot of things to set up and discuss here. Let's jump right in and take a look at our calibration file and where we want to start. So the very first thing we're going to find when we're beginning setting up two-dimensional and three-dimensional tables is that we have to look at over here our tuning window. We're going to begin over on our fuel side. We can see once we move through the drop-down, we have a lot of different things we can select. So this is going to be where we get into some configuration details that we have to be mindful of. Now, first things first, let's take a look here at our main VE table. We can see main VE table 1. Now in this case, this is usually what you're going to find for your air mass model when you're tuning typical engine. Now, Honda K series engine is a little bit different because we have a low and a high cam profile that changes up the engine's breathing and therefore the volumetric efficiency of our engine. So what we're going to find is when VTEC is off, we want to assign our main VE table 1 to our low cam operation. And then when VTEC is on, we want to have main VE table 2 for that high cam of operation. We want to switch between them with our VTEC functionality. Now, this is the way that Honda dials in and calibrates their engines with the factor ECU, so we're going to mimic that same type of strategy. Let's take a look at what we're going to do in order to accomplish this. So first thing we're going to do is jump in here to fuel, and we're going to move down here under our fuel table control, and we're going to move in here to our main VE table. This is going to allow us to have various different main VE tables. We can have more than one. We can go under our V table control here, and we can see that right now it's currently set to on table 1. This is typically what you'll find for most engines, but again, we're looking to go and set this up on, in this case, our Z-axis control. So we're going to be looking here on Z-axis. So we're going to change this number to a 6. So in here, we're going to allow it to jump back into the main VE table 1, and we can find now we have main table 1, main VE table 2, main VE table 3. We actually have 3 different tables that we can set up and we can configure. So what we're going to do here is essentially eliminate main VE table 3 and only work with table 1 and table 2. In order to accomplish this, we're going to have to go in here to our Z-axis setup and go into our fuel main table Z-axis setup. Now in here, we can see this table is based on ethanol concentration. We want to change this up a little bit, and we want to change it on cam control switch state. If we go here and we go ahead and click A, it's going to allow us to re-index our axes and change this from ethanol content to cam control switch state. Let's go up here to select, and I'm going to type in here cam, and we're looking at cam switch status and clicking OK. Now here, we're either going to be a 0 or a 1 status. So what I'm going to do is just go into the table here. We're going to clear all. Starting value is 0, and we can just go ahead and populate another value here at 1 and click OK, and then click yes. And now what we're going to find is that we have our Z-axis configuration and setup. Now what we have to do from here is either set this up on, in this case, a 1, a 2, or a 3. So when the cam control switch status is 0, we're using our main VE table 1, so we'll have a 1 here, and then our value of 1, cam control switch status 1 means VTEC is on, or cam control switch state is turning our VTEC solenoid on through that aux output we've assigned. We're going to go ahead and assign it to a 2. So a 2 means we're using our VE table 2, a 1 means we're using our VE table 1, and we're switching between it based on our cam switch status. Very simple. So now if we use our escape key and jump back up to the top here, we have our main VE table 1, and we have our main VE table 2 that we're going to potentially be using here, depending on which cam control status that we're operating on, low cam, non-VTEC, or VTEC, and then our VE table 3 is not going to be used. We can ignore this and not have to populate or worry about anything in our VE table 3. Now, we can go into our VE table 1 and assign our axes a little bit more in depth for the engine that we're trying to control. So we have to take a look at 2 different things. One, we have an efficiency calculation here. This is our percentage. And then we have our engine speed up at the top. Now, when I'm talking about and dialing in my low cam, I'm not going to be revving the engine past probably 7,500 RPM. We see the table here is populated at 8,000 RPM, and that's fine. I'm going to leave it there for this particular low cam example in terms of our breakpoint resolution, or how many RPM points we have to move through here in our table. What I am going to do here is just chop down some of our lower breakpoints. I'll do one at 0, and then 500 and 1,000. I'm going to get rid of 250 RPM. I'll even get rid of 750 RPM. So let's just do that real quick. We'll click A. I'm going to go ahead and delete this specific site right here. And actually what we can do is clear all, starting value of 0. Let's do a 500 RPM increment. And the total sites here, we're gonna have to guess on some of these numbers. Let's see what that goes to. Now we need more than 15 sites. We'll populate it out to 8,000 RPM. Let's go to 17 sites. So there we're going out to 8,000 RPM. That's perfect. So it's moving in 500 RPM increments. We're not gonna really idle much below 1,000 RPM, which is why I don't wanna have a lot of resolution wasted in the table down here below. The other thing to consider here is our y-axis. This is our efficiency calculation. Now we've set this when we were configuring our details in that last base map creation tutorial. We've set this to TPS over baro pressure. And essentially what's happening here is that it's going to be translating between 0 and 100% throttle in the breakpoint resolution here. So 0 to 100 is our throttle movement, and it does factor again that baro pressure in the calculation. Now, what we're gonna have to do from here is change up our breakpoints a little bit. We're gonna have a starting value here at 0, and then our increment, we want it to move in maybe 5% increments. Let's see what's gonna happen here. We'll clear all and then generate, and we can see it's gonna go out here only to 80% throttle. We can go out here, maybe have 20 sites, and that's gonna go out here to 95% throttle. We wanna go all the way out to 100% throttle. So if I click OK, click yes, we've reconfigured the table here. So now what we're gonna find is that we have all of this resolution for our throttle position breakpoints. Now, if I go in here into the table, I can reconfigure this a little bit more specifically. Let's talk about this. I probably don't need as many breakpoint sites. I do want to have it sweeping between 0 and 100%, but once I'm getting up to, let's say 60, 50% throttle, I don't need to move in, let's say 5% throttle increments. There isn't really any benefit for having that much resolution in the table, but we do want a whole bunch of resolution on the low end. So 0, 1, 3, 5, 7, 9, 12, and 15% throttle. That is going to be breakpoints we want to move in about 3% throttle increment, because we have a very unlinear relationship between airflow coming into the engine and our throttle blade movement. So we need to have a lot of resolution on the low end, and on the top end, we don't need as much resolution. Again, we can skip and have a little bit larger breakpoints to properly characterize the airflow for our engine here, and working with this alpha end strategy. This is going to be alpha end base. We're not using traditional map pressure for the efficiency calculation. We're using throttle position, throttle over baro pressure. So in this case, we could probably shrink the number of sites down here, and I could probably shrink them to something like, let's say 16 total sites. And we can see here, if I do a clear all and generate, we can see it's going only out to 75% throttle. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.